All right, so we're going to talk about lesson 2.7 today. By the end of today's lesson, you should be able to solve polynomial inequalities and solve rational inequalities. So if you look at the first example, it says solve x squared minus 5x minus 6 is less than 0. I have the steps over here. It says get a 0 on one side of the inequality, find the critical values, which are the zeros of a polynomial, test the x values between the critical values, and then write and graph your solution. So step 1 says get 0 on one side of the inequality. We have that already. Step 2 says to find the critical values. Well, the critical values are those values where the sign changes from a positive to a negative or a negative to a positive on the number line. So first I'm going to just kind of factor this out. So x squared minus 5x minus 6. So when I factor that, I get x minus 6, x plus 1. So my critical values are going to be, in this case, where x minus 6 is equal to 0. So that would be x equals 6. And where x plus 1 is equal to 0, which is negative 1. So what we're going to do is we're going to test x values between these critical values. So I'm going to just essentially make a number line. So I'm going to put negative 1 on the number line and 6. So again, these critical values are where the graph may be positive and then it will flip to negative after negative 1, and the same thing with 6. So I'm just going to pick some test values. I'm going to pick something to the left of negative 1, so let's test negative 2. Something in between negative 1 and 6, let's pick 0. And something to the right of 6, so let's pick something like 10. All we're trying to figure out is if those intervals are positive or negative. So you don't actually have to fully calculate. So if you plug this in, so if I plug in negative 2 minus 6, that would give me a negative value. If I plug negative 2 in for x, so I would say negative 2 plus 1, that would be a negative value. So that means that a negative times a negative, this interval will be positive. 0, if I plug in 0 for x, in the first parentheses I would get a negative. In the second parentheses, 0 plus 1 would be positive. So in the end, I would get a negative interval. If I plug in 10, 10 minus 6 is 4, so that's going to be positive. 10 plus 1, so that would be positive. So in the end, this interval is positive. So we go back up to our original problem. We want to know where x squared minus 5x minus 6 is less than 0. So if it's less than 0, we're looking for all negative values. So we're going to look from negative 1 to 6 and all the values in between. So our final solution in interval notation would just be negative 1 to 6. Okay. All right, we're going to look at the next one. So the next one says solve x cubed minus 4x squared minus 12x is greater than negative 16. Well, step 1 is you always have to have 0 on one side, and we don't. So let's move over this 16 by adding it. Now we have to find our critical values. So essentially we're going to factor this to figure out where those sign changes occur on the number line. So this looks like a good candidate for factor by grouping. So if I group the first two terms, I can take out an x squared. If I group the third and fourth term, I could take out a negative 4. And then bring down the greater than 0. So if I rearrange this, pulling out the GCF, I would get 3x minus 4 times x squared minus 4, which is greater than 0. So hopefully you remember that this x squared minus 4 is a difference of squareds. So I can break that down to x plus 2, x minus 2. So let's find the critical values. So if I set 3x minus 4 equal to 0, I would get x equals 4/3. If I set x plus 2 equal to 0, I know that negative 2 is another critical value. X minus 2 equal to 0, positive 2 would be a critical value. So I would put these values on the number line. So the smallest one is negative 2. 4/3 is like 1 1/3, so that would be next. And then 2 would go all the way to the right because it's the most positive. So I just have to pick some values to the left and to the right of these critical values. So I can pick something to the left of negative 2, we can use negative 3. In between negative 2 and 4/3, you could use 1. 4/3 and 2. Well, 4/3 is 1 1/3 and 2, so I would use something like 1.5. And then to the right of 2, let's use 3. So again, we don't have to exactly figure out what the value is. We just need to figure out if it's positive or negative. So if I plug in negative 3 into this inequality right here, so let's see, negative 3 times negative 3, I'm sorry, 3 times negative 3 is going to be negative 9 minus 4, so that's going to be negative. If I plug it into x plus 2, so negative 3 plus 2, that would give me a negative answer. And then negative 3 minus 2, that would give me another negative. So a negative times a negative times a negative, that would be a negative interval. So if you plug in 1, 3 times 1 minus 4 is going to give you a negative value. If you plug it into x plus 2, that's going to give you a positive. And then 1 minus 2 is going to be negative. So a negative times a negative would give us a positive interval. So if I plug in 1.5 times 3 minus 4, that's going to give me a positive value. 1.5 plus 2, that's going to give me a positive. And then 1.5 minus 2 is going to give me a negative number. So a positive times a negative would be negative. Hopefully you're noticing the pattern on the number line. Negative, positive, negative. We could almost predict what 3 is going to give us. So if I plug in 3 times 3 minus 4 would be a positive number. 3 plus 2 would be a positive. And 3 minus 2 would be a positive, so this is going to be a positive interval. So we have to remember, what are we looking for? We're looking for values that are greater than 0. So we're looking for all positive values here. So that means that I'm looking from negative 2 to 4/3 and all the values in between, and from negative 2 on. So what would that be in interval notation? So that would be negative 2 to 4/3 and 2 to infinity. All right, let's look at example 3. So example 3 says solve x squared plus 6x plus 9, which is greater than 0. So if I was to factor the left-hand side, because we have the right-hand side is already 0, we would get x plus 3 squared, which is greater than 0. So if I was to set the left-hand side equal to 0 and solve, so we could say x plus 3 squared equals 0. Well, we take the square root, so you get x plus 3 equals 0. Subtract, so you know the only critical value is at -3. So if I make my number line here, and I put -3 on it, we want to test something to the left and to the right of -3. So if I pick something like -4 and to the right of -3, and the number line would be 0, and I plug it in. So if I plug in -4 plus 3 squared, that's going to give me a positive value. If I plug in 0, 0 plus 3 squared, that's going to also give me a positive value. So we want all values that are greater than 0. So that would be from all of these negative values to 3, and then to the right, all of these values to infinity. So how would you represent that in interval notation? So that would be from -infinity to -3, and then from -3 to positive infinity. Essentially, it would be all values except for -3. Because think about it, if you plug in -3, it's going to be equal to 0. And we don't want values that are equal to 0, we want values that are greater than 0. Okay? Any questions on that one, make sure you ask me in class. All right, for number 4, it says x squared plus 5x plus 7 is less than 0. So unfortunately, we can't factor the left-hand side, but we know other methods to solve. So we can either use completing the square or quadratic formula. So I'm going to use quadratic formula. So I would say x equals -5 plus or minus the square root of 25 minus 4 to AC, so times 1 times 7, all over 2 times 1, so that would just be 2. So I would get x equals -5 plus or minus, and then underneath the square root I have 25, and then this would be minus 28 over 2. So if I look, I would get -5 plus or minus -3 over 2. So I could stop at this point, and I realize that I am not going to have any real solutions. I'm not going to have anything to put on my number line. So this is the example of the empty set or no solution. All right, number 5 is a lot more interesting. It says solve 3x minus 5 divided by x minus 3 is less than or equal to 1. Our step 1 is to always check and make sure 0 is on one side. So it's not, so I'm going to have to move over this minus 1. So now that on the right hand side I have 0. Well, I have a fraction, so I'm going to have to get a common denominator here. So I'm going to multiply this minus 1, the numerator and denominator, by x minus 3. So then I would get 3x minus 5, and then I can distribute a -1 here, so it would become -x plus 3 over that common denominator. So if I simplify the numerator, I would get 2x minus 2 over x minus 3 is less than or equal to 0. So if you ever have a fraction, the critical values are either going to make the numerator or denominator equal to 0 here. So if I set the numerator equal to 0 and solve, I would get 2x equals 2, so x would equal 1. And if I set the denominator equal to 0, I would get 3. So my critical values here are 1 and 3. So if I put them on the number line, and we're just going to kind of plug in some values. To the left of 0, to the left of 1, I'll use 0. In between 1 and 3, I'll use 2. And to the right of 3, I can use 5. All right, so if I plug in 0, the numerator would be negative. The denominator would be negative, so a negative divided by a negative would be positive. So this interval is positive. If I plug in 2 into the numerator, it would give me a positive value. If I plug in 2 into the denominator, it would give me a negative value. So that means that this would be a positive divided by a negative would be a negative. So then 5, if I plug that into the numerator, 2 times 5 minus 2 would be a positive. 5 minus 3 in the denominator would be positive. So positive divided by a positive would be a positive. Notice the signs always alternate. Hopefully we're kind of realizing this by this point. All right, do you notice how it said less than or equal to? Okay, so we have to think about what that would mean with our number line. So instead of using a parentheses, I'm going to now use a bracket at 1. Because we want values that are less than or equal to 0. So that means this middle interval from 1 to 3. But then you have to stop and think. Can 3 be a bracket? Can it be included, or would it be a parenthesis? Well, in this case, it would be a parentheses because notice 3 is in the denominator. If you plug that in, you're dividing by 0, which is not allowed. So your final answer would be a bracket with 1 and a parenthesis with 3, and that would be it.